In our next section, we're going to look at some of the miscellaneous features of label distribution protocol. Specifically, we'll talk about how to do authentication in LDP, how do the IGP session protection or the IGP synchronization and the session protection features work, and then also how we can configure what specific label numbers we're going to be using when we allocate, and then also what specific labels are we going to allocate in terms of matching the IPv4 addresses, and then also what labels we are going to be advertising on a per neighbor basis. Now, the first of this in terms of LDP authentication we'll see is very similar to BGP, because like BGP, LDP uses TCP for transport, and TCP authentication is already defined in an RFC as TCP option number 19. So it implies that we can just add the MD5 hash into the TCP header and then authenticate any of the LDP peerings. Now, what can be kind of confusing about this, though, is that when we actually go to configure what neighbors that we want to do the authentication for, remember that there's a difference between the interface address, the IP transport address, and the router ID. But in this case, since we are doing the authentication on the TCP header, we want to be matching what address the TCP session is actually going to. So like in our particular case here, we have an LDP peering that is going between router 1 and XR1. It is sourced from router 1's loopback, which is 1111, and it is destined to XR1's loopback, which is 11, 11, 11, 11. This means that when we actually go to specify what is the address that we would want to authenticate, it should be matching against these particular addresses. Now, from a configuration point of view, we'll see that there's a number of different options in order to do the authentication. We can do it on a per neighbor basis, we can do it on a per group of neighbors, or we could do it as a default password. But ultimately, the end result is the same, that we're inserting the password, or the MD5 hash more specifically, into the actual LDP exchange. So before we actually configure the authentication, let's go ahead and start a new packet capture. And specifically in this case, we're going to be looking at just TCP traffic, because TCP traffic, that's going to be the actual LDP adjacency and then the keep alives that are going between the neighbors. And on router 1, if we look at the show MPLS LDP neighbors, the peer that we are connecting to is 11, 11, 11, 11. And we can see that there are 3 different fields here. It says what's their identifier, what's the TCP connection, and then what are the specific addresses that are bound to the peer in terms of what links are we potentially routing with them. So next we're going to go to global config and say the MPLS LDP neighbor, which is 11, 11, 11, 11, is going to have a password associated with them, and we'll say that this is Cisco 1234. If we now look at this from the packet capture point of view and look at frames that are coming in from router 1, we should see the next keep alive that goes to the neighbor 11, 11, 11 should have TCP option number 19 set, which is going to be the actual authentication. And we may need to clear the neighbor in order for this to apply. And actually, no, that was the packet source from 11. I want the packet sourced from 1. So from 1 to 11, and it looks like it's not in the header here. Okay, so next on router 1, let's look at the show MPLS LDP neighbor, and let's say the specific address, so 11, 11, 11, 11, and look at the detailed output. So it says that for the neighbor, the password is not required. This just means that we need to reset the session in order to get this to actually apply. So if we look at the show run include MPLS, the password is configured, but right now it's not actually doing anything because the TCP session was already established. So similar to like in BGP, if you change something that relates to the TCP options, you need to clear the BGP neighbor in order for it to actually reestablish with those new options. So in our case here, let's say clear MPLS neighbor, clear MPLS LDP neighbor, 11, 11, 11, 11. And if we look at then our capture, we should see that those new frames that are coming in, which will be these ones here. Okay, we can see router 1 reset the session, and then it is going to, should be trying to start the session to 11. Let's say this. Let's say that the IP.source is equal to 1111 and the IP.destination is equal to 11.11.11.11. And let's see, router 1 should now be complaining. It says no MD5 digest came in from the neighbor. So it really depends on who was the TCP client, who was the TCP server. In this case, 11 is the client. So router 1 is getting the SYN in. It says it doesn't match the password that I have. So router 1 simply doesn't reply. It just ignores the packet. Okay, if we were to go to the other side from iOS XR's point of view, when we look at the show run and just look at under MPLS, just like in terms if we were to do ISIS authentication or OSPF authentication, it's going to go under the global process. So in this case, we'll say under MPLS LDP, the neighbor is 1111, and the password is going to be, we'll say it is in clear text, and the password is Cisco1234. Okay, if we look at the capture of this, the end result should now be that we see in the TCP header. Okay, so here's the actual LDP exchange. This is the label exchange. We should see now that there is okay, we can see these are the actual routes that they're exchanging. So this is the prefix, and then this is the label that they're advertising. I know, let's see, what is the label? The label is message type is the label. I think this is the label number encoded, but basically this is like the routing exchange that's happening between them. If we look at, let's say, just a keep alive between them, so from 1 to 11, the authentication should now be in all of the keep alives as well. And here it is, TCP option 19. So this is here somewhere, which is, where's the actual signature? But this, you can tell, this is where the authentication is happening. So the point being is that when you match the neighbor, you need to match where the TCP session is going to, where the TCP session is coming from, because the password goes in the actual TCP packet between them. What would be the common misconfig for this is on, let's say, like between router 1 and router 2, where we have an LDP peering that's using this particular interface, and then if router 1 were to say that the MPLS LDP neighbor is 10.2 or 10.1.2.2 with a password of router 2, and from router 2, we do the same thing, but we do it with the MPLS LDP neighbor 1111 has a password of R2. And we clear MPLS LDP neighbor 1111. When the neighbor comes back, we should see that it says there's no authentication. So even though router 1 does have a password configured, it's basically matching against the wrong address because the TCP session is not going to 10.1.2.2. The TCP session is going to the loopback, which is the router ID. And again, we can see this when we look at the show MPLS LDP neighbors, and we look at the session that goes to router 11. It should say here, let's say neighbor 11.11.11.11 detail. It says that MD5 is on. Now, there are some additional options here that you can set differently in regular iOS than XR. In this case, it says that the password is not required, but it's actually using it for the neighbor. And let's take a look at this from the scope of the documentation. So in regular iOS, let's go to the command reference. Let's go to iOS XE, and then under command references, we'll go to the MPLS command reference, and then these are going to be under MPLS LDP. So specifically, this will be the password fallback, password option, and password require, and then also the rollover. So right now we're saying the neighbor password option. This would be, or actually we're not saying neighbor option, we're just saying neighbor password. This says, and actually that would be under MPLS LDP neighbor, neighbor password. Okay, so this is where we're saying use the TCP MD5 option to do authentication, and it says that the IP address is the router ID, the IP address that advertised the neighbor. So again, because the router ID becomes the TCP transport source, that's typically why you would be using the loopback here for this particular authentication. So not the interface level. But beyond this, you can say, so I want to do authentication, but I want to do it in general for everyone. So I'll say that there's a fallback password. This would say if there's not a specific match on an individual neighbor, we're going to fall back to this one as the global password. And there's another option where you could say that is the password actually required or not. This would say if I have a neighbor, I don't have the password configured, I have a fallback password configured, but if the password is not required, I could ignore that and still set up the TCP session with them. So for example, if we were to go to router 2 and we were to say that the MPLS LDP password, fallback password is fallback, and we then clear MPLS LDP neighbor star, the neighbors go down, and now it's saying I'm complaining that I don't have authentication for these particular neighbors because we're falling back to the default password. You can then say, do I actually want this to be required or not, and for what particular neighbors? So let's say that the password is only going to be required for 13 and 3. It's not going to be required for 12 or for 1. So we would call this in a standard access list, and the access list is going to match what are the particular neighbors that we want to use the password for. So if we said access list 1 permits 3333 and permits 13, 13, 13, 13, and then say MPLS LDP password is required for who? It's going to be required for peers in ACL1. So this means that we should stop getting the message that we're missing a password from 12, because 12 is no longer required to actually do the authentication. And let's say clear MPLS LDP neighbor star. And without going over all of the variations for this, you can see an example of this in the SP workbook. So let me go ahead and open up the link to that. And we'll see that these other type of topics here in miscellaneous features, really where you need to go in order to figure this out is both the configuration guide for LDP and then also for the command reference. So I would spend some time here, go under where you have this section here that starts at MPLS LDP and then down through the next one as well. Just go through this list top down, and then for anything that you don't know what the command does, just click on it and then read through whatever the usage guidelines are. Okay, so the MPLS LDP auto config, we talked about this one before. It says this works with MPLS LDP auto config, which enables LDP on all interfaces that belong to an OSPF area or to ISIS. Then this says, well, you can selectively disable it at the port level if you want to. Otherwise, in our case, this would be LDP authentication. So under MPLS, under LDP authentication, and okay, so in this case it says, router 1 says the password is required. A password option 1 is going to be used for these particular neighbors, and this is the password. So the neighbors are matched in this access list. We're saying if the TCP session comes in and it's coming from 3333 4444 6666, they're going to use this particular password. Otherwise, if it's a peering that goes to 2222, they're going to use this specific one. Then at the same time, you could say, well, what if I don't have a match for them at all? That's when they're going to go back to the fallback password. Okay, and MPLS password required says that you have to authenticate. And like as I showed, you can also call an access list on top of this. In terms of iOS XR, there's a limit as to what you can do with this. You can basically either say, this neighbor has this specific password, or you can go to the fallback password. But otherwise, it doesn't have as many options in terms of use this password for this particular neighbor and then fall back to a different one for a different group. It's basically just one or the other in either case. But as we saw here, it's a fairly easy problem to figure out if authentication is broken, because as long as you have logging enabled, TCP generates this syslog message. The same exact message that we would see if there's a BGP peering that's doing authentication and we had the password that was missing between them. Okay, but other than this, the big common mistake is that if you match the wrong address, so you're matching again what is the transport address. It's going to be what their normally what their router ID is. Okay, so let's remove the basically just all three of these. Okay, so now we should see router 2 forms the adjacencies to XR1, XR2, router 3, and then also to router 1 here shortly. Show MPLS LDP neighbors. Okay, also to router 2.